Continuing on with our notes for lesson 14.2, talking about sets of numbers. All numbers that can be observed are called real numbers. So let's look at these types of numbers and think about whether we can observe them. So we have, for A, 1/2. Well, how about half of a pizza? B, we have -3. Well, if anyone knows anything about golfing, which I know very little, but I do know that -3 would be a possible golf score. I encourage you to think about these, and maybe there's something else you're thinking about as a way that you can observe these numbers that I'm not saying, and maybe write that down as well. C, we have 28. So maybe that's the price of a shirt you want to buy. D, we have pi. Well, maybe that's the circumference of a circle that has the diameter of 1 foot. And the last one, we have -3/2. Well, for one, -3/2 could be written like -1.5. And one way that I can observe that is thinking about my kids' lunch account. When their balance for their lunch is -$1.50. Or maybe you owe your friend $1.50. That would be represented with a -1.5. So thinking back to all of the definitions that we talked about on the front page, and then concluding with real numbers, we notice that all of them overlap. All whole numbers can be written as a fraction. Oops. So they are also considered a rational number. So to sum that up, a whole number is also a rational number. So now we're going to use this diagram here to just get a better idea of how these sets overlap or like fit within each other. So over here on the top here, this big idea here, we have real numbers. And then this little column over here to the right is where we have our irrational numbers. And then, like I said, thinking about how they overlap, the very small circle, those are our whole numbers. And a whole number can also be an integer. So then we have our integers, and we know that integers are rational numbers. So since there are circles inside of circles, inside of those boxes, like I said, those are sets inside of sets, some of those numbers actually belong in many of those sets. So let's use an example here. So let's talk negative 14. So let's determine which set or sets of numbers does negative 14 belong to. So is negative 14 observable? Well, let's think about that. Maybe I have $14 in my, or maybe the school lunch balance for my kids is negative 14. Well, that would be observable. So therefore, negative 14 is a real number. Can negative 14 be written as a fraction? Well, yes, it can. I can write it as negative 14 over 1. So therefore, negative 14 is a rational number. Does negative 14 have a fractional or decimal value? It does not. So therefore, it is an integer. And is negative 14 a positive number? No. So it is not a whole number. So what we can conclude is that negative 14 is a real, rational integer. So let's look at the diagram above to see where negative 14 would go. We know that it is not a whole number, so we will not put it in the smallest circle, but we will put it where the integer circle is, because we know that the integer circle is also within the square of rational numbers, which is under the umbrella of real numbers, which is what we see that negative 14 is.